Specific questions?
I have a question. You talk about the implementations of Amazon and Google, and that's clearly a place where. But what in the commercial companies, what kind of companies do you see that are what industry segments, for instance, are looking more at using Hadoop as a technology? Where do you see that? What kind of businesses or industries do you see looking to adopt Hadoop?
I'm sorry. I'll just repeat it just for mic purposes. But just what industries other than, Yahoo and Google? They're all obviously in the, web-based industry. What other industries, right? Does it really apply to companies outside of the web properties, if you will? And I think the answer is yes. If you look at retailers, all the top retailers have it. A common use case for that is ingesting POS data, right? That's a lot of data coming in very fast, and there's more attributes about it. There's more attributes about the customer, and they want to do market basket analysis across many years to see trends and patterns. So retailers are using it. Banking, very big in banking. The top bankers all are using Hadoop, and some of that's because of volume of data. Some of it's because of the ability to go against more data, fraud analytics across everything. Very common. Complex things like Monte Carlo simulations and risk analytics, very easy and very good to do in Hadoop because of the processing power. Government, I think that was mentioned. They have lots of information about lots of people and satellite imagery, very unstructured data coming in. So that's a real common. Healthcare, again, lots of customers, lots of data. If you think about a hospital, the information coming in is not always structured. It could be a picture. It could be x-rays. It could be documents that have been scanned, healthcare pieces of information. Tons of data that they want to be able to look and get a central view across either all of the customer or all of that incident. So weather, of course, weather's everywhere. So I think the answer to that is big companies, small companies that have lots of data, complex data, and realize that there's some efficiencies in doing it in this platform. It can be done less expensive than buying big mainframes and appliances to scale to that level. So,
I'll just echo a couple of things that Chris said. You used a term that I don't think comes up a lot, but that I use is Monte Carlo. If you look at companies that are doing Monte Carlo simulation, Monte Carlo simulation involves diverse events and therefore often diverse data. So any place where Monte Carlo simulation is being done, it's applicable. I talked about bioscience, but I kind of talked about the technical side of bioscience, and Chris pointed out healthcare. Any industry, especially healthcare, where you have diverse sets of data, medical records in this case, right? Medical records, billing records, prescription records from diverse sources. Healthcare is, I would say, is probably a poster child because of the problem that we have, especially in this country, with medical records. I'd also point out, we see, and this was on the slide talking about manufacturing. One place we see it used is, I talked about process yield, meaning customers taking, to understand what their manufacturing yields are or how to improve them in manufacturing processes by collecting large amounts of, again, seemingly unrelated data, environmental data, robot sensor data, actually performance of the product in the field after it's produced, and then cross-correlating all that to determine what might have occurred at the time of manufacture that leads to that state, and therefore producing better product performance in the field or better yield out of an assembly line. So it's not very limited, I think, as to how it would be applied.
I had a question because generally with Hadoop and some of the technologies, when you equate it to search engine technology, where it's really analysis at the top layer rather than the deep analysis where, say, you use a tool like SAS or something else where you're doing cluster analysis or you're doing neural nets. where you're doing biological analysis, where you're getting into a layer of what an analysis that far exceeds what a Monte Carlo what if simulation could possibly do, and machine learning. What are the capability limitations as you see them with this technology? And then in addition to that, one of the challenges with technology today is you have sort of the operational data store and then you have the transactional data store. How does this technology address the two?
Yeah, so I'll take that one. You mentioned, first of all, the search index case. And what Hadoop is really good at is parallelizing lots of work that has to be done over large portions of the data. So really, the actual process of being able to index all that information is great for Hadoop, especially if you're trying to do those correlation between subsets. There's a project that's part of the ecosystem called Mahout. That's in a library of machine learning algorithms that people are using now with Hadoop. A great use case would be if you look at something like an Amazon.com, and what happens when you go to look at a particular item. Maybe some of us have been to that site once or twice and decided that we wanted to buy a book. And sure enough, it tells us that, these other 3 or 4 books are things I might be interested in. And, it's usually actually pretty close, right? They usually are things that you are interested in. So what actually happens behind the scenes is that each one of their products is actually getting indexed and cross-correlated to other products based on the traffic patterns, how people have navigated the site, navigated the product set, and all that batch processing to build those correlations happen in a massively parallel environment similar to Hadoop. Of course, then, at the transactional level, when someone's browsing the site, those results are actually then put into a type of database that you can then do the actual real-time lookup. So Hadoop is really good for doing those aggregations, preparing the information, whether it's for a data warehouse or for an application operational system to be able to do that. Does that help?
Yeah, you mentioned machine learning, and you mentioned Mahout. So that's a separate Apache project, and that's I'd refer you to Mahout. There's really entire groups of engineers, and at least in the Hadoop meetup meetings that I've been, focused specifically on machine learning and the Mahout implementation, and that might be useful to you if you're looking at machine learning.
And that's a great example of a project that the more it gets used, the more libraries get contributed, the less work there is for you to find a library that's close to the problem you're trying to solve and just customize it.
But there may be a tool like a SAS, as you mentioned, that wants to access data that's in Hadoop or use that processing engine. So you'll see a lot of the BI tools build connectors into Hadoop so that is a source and an engine that they can leverage. SAS is one of them, MicroStrategy, Tableau, R, which is another statistical, because they want to leverage the power of going against all the data and leveraging that engine that runs it for it, which is MapReduce.
And they may not use Hadoop on the back end for the operational reports, but especially with SAS, when you want to execute complex procedures, do you want to have to pull out the data back into an environment and then process it, hopefully not in series, but closely in series? What if you could actually leverage a grid-type environment like Hadoop where the data actually resides, right? So there's both. There's connectivity to be able to run reports and bring data back, and then as Chris mentioned, there's the power of using the engine of Hadoop and the parallelization of the process. So.
Question
over here.
Yeah, so you do all this analysis, you get this return of massive amounts of information. For humans to consume it, so you mentioned not only the GUI that's a part of the Apache folio ecosystem. You also mentioned, I think, Quantum 4D was one of the tools that you've seen for visualization. What does Cloudera use when you go in and implement for a client?
So the CDH stack that Cloudera provides is a number of different projects: Mahout, Hive, Pig, as well as the core MapReduce. They're not necessarily visualization layers, but they do provide access layers. So Chris mentioned that particular BI tools, Tableau, MicroStrategy, several others, has actually taken advantage of the ODBC high-speed connectors that Cloudera has built on top of the Hive project. So people can use the Tableau visualization layer, MicroStrategy. What's actually probably a more common use case pattern is for people that have hundreds of users, hundreds of report writers who want to take advantage of this information that's been aggregated. They actually still use their data warehouses and their typical tools, but they actually feed that information into the warehouses from Hadoop. So because Hadoop also has high-speed relational connectors, using Apache Scoop, which is one of the projects in CDH, you can actually take this data, ingest it in raw form into the Hadoop environment, do lots of the transformation and processing to create the aggregated data sets that you typically do your analysis on, and then use those to feed into the warehouse. So you parallelize and optimize the process of transforming all that information, and you can now make it available to those hundreds of users. Now, in a lot of the use cases that Chris mentioned, like the financial services, the fraud, analytics, there are always going to be a small number of power users that want to access not the aggregated information that you typically make available in a warehouse, but the actual raw data. Whether that's because they're quants, like I mentioned before, or whether it's because they're doing fraud analytics. Those folks that look for the visualization layers and the connectors through things like the Hive or the CJ drivers, as well as several third-party tools, to be able to come in, use typical SQL languages if they don't want to program directly in MapReduce to actual access the data. So that ecosystem is growing.
That's the latter part is what I was thinking about.
Yeah, and they're typically designed for a subset of users, not 500 concurrent report writers. Right?
Appreciate it. Thanks.
In addition to analytics, you talked a little bit about the self-healing nature of HDFS, the redundancy of HDFS. What additional add-on value can you get other than analytics? I've heard about some companies, I don't know what success you may know of this, to use it for things like backups or storage, just so that you can go to management and say, in addition to all this great research and analytics we can also replace, or what add-on value can you get from
I'll take that. So the question was the add-on value beyond what you would see in traditional analytics. And sometimes it's the flip. You can justify the whole thing by getting rid of a tape file system. Some of the big customers that we work with spend millions of dollars backing up data, and it's not accessible. It's effectively dead at that point. So if you can more cheaply store it in Hadoop, right, compress it, but still make it accessible, that's huge value. So you're getting a lower cost solution, providing more value because it's accessible, and you can do it over a longer time period. So sometimes that's the best starting point because the ROI is immediate. And we would recommend that. If anybody is ever doing tape backups, you just know the cost. It's a cheap to get it on there. It's costly to get it off. So that is a big use case. The other one is, I think that kind of surprised us, if you will, that happens is companies are running out of their daily window. They have SLAs. Something has to run in 2 hours. And existing technologies cannot crunch through it fast enough. Right? So they've kind of hit a wall. I mean, some of the banks have to run things by law in 24 hours, and they were running things in 26 hours. That's a huge problem. They can convert that to Hadoop, and in one particular case, it was down from 26 hours just to a couple hours. So that actually creates opportunity because now they can do more intraday updates, and they're not just always trying to get it under the window. So meeting SLAs, tape file storage systems, or common other use cases for it other than just BI and analytics.
I'm going to add and maybe turn your question upside down that so as you pointed out, HDFS has built-in resiliency. It was architected that way. It was designed that way. There are implementations of MapReduce that are not built on HDFS. So I think one of the things that you also need to consider is me personally, I just reduce it to obviously resiliency costs you something, right? It costs you at least the space to store and have backup copies of your data. I think our view is that that's part of the value of HDFS and why you want to employ that file system with MapReduce. Of course, you can go to file systems that eliminate the resiliency, and therefore you eliminate part of that abstraction. They can be faster, and there's lots of. I'm bringing this up because I think you might get into this discussion about, well, do I have to use HDFS, or what's the value of HDFS? HDFS was designed to be resilient. It was designed to run on relatively inexpensive hardware and to deliver all that value. And I think it's very good at doing that. You can get caught in kind of a religious argument about, well, would it be faster to do this? Well, of course, if you eliminate all the resiliency in the system, it can be much faster to process it a different way. that's not necessarily what you want. So it's back to the question, I think, of what is the solution that you're trying to design, and what are the needs that you have for the data, including resiliency, and does that serve your need? So hopefully that helps a bit.
I'm relatively new to the world of big data, so this is an educated question. It sounds to me like you clearly addressed 3 of the 4 big V's, being the velocity or the speed at which data is coming in, the volume or the amount of data which is going in, the variability of the data types that's ever increasing and coming in. The real so what who cares question is the visual aspect of it and how the end users can consume it. It seems like a lot of the architecture out there or the BI tools are based on an older paradigm. What training are you seeing to be able to visualize and make project business sense out of all this information that's coming out?
So there's two fronts to that. One is, if you talk to any of the BI companies, they have a Hadoop strategy. They're going to connect to it because there's too much opportunity there. And if they don't, other people will. So R was developed for Hadoop and statistical analytics. Well, SAS wasn't going to let that just hand all of the Hadoop business to R. So of course, they're now going to port their piece to it. So I think what we're seeing is on the BI side, those tools will build connectors in various ways to access information. Some of it will leverage the Hadoop infrastructure more fully than others, but you'll be able to access it and connect to it. What we're also seeing, though, which is less mature even than that, is an industry of opportunity for new companies that are engineering interfaces such that users can consume information, and it's built on Hadoop. It's built for Hadoop, such that it, out of the box, was built and architected to leverage the infrastructure that's in place there. So we're going to see a lot of new products probably coming out in the next 12 months that are built for purpose, built for Hadoop-type systems.
What would you see a trend being? What are some of the shortcomings and some of the breakthrough, the tipping points of innovation in regards to visual aspect?
So I think that probably the biggest thing you can imagine with it is if you're going against 2 petabytes of data and someone asks the wrong question, it can be very consuming, right? Or in a traditional database, you can highly index things so that it always comes back very quickly, even if you have a lot of data. But that kind of goes against the paradigm of being able to store all pieces of information. So I think what you'll see is that those technologies will protect the user from doing something that maybe they really didn't want to do anyways, right? I don't want to bring back 2 petabytes, but I do want to scan 2 petabytes to find out if there's some fraudulent activity that's happening or clusters of information that make sense for it to bring back that smaller subset, which is consumable and which is actionable based on whatever event it found in that data. So I think those protections are going to start being built into the technology, knowing that it's potentially petabytes.
So I would add to that. So we would see. So the video industry already implements this and knows how to do this. They do like video transcoding. So for example, they recognize what kind of client you're on. And I was talking in the lobby about, we have ubiquitous clients now. You never know what client you're accessing your data from. And for data analytics, in wanting to consume data analytics in real time, you may need to access it from your iPhone. You may be accessing it from a 4K display in a computer room. You may be accessing it from a desktop. You may be accessing it over a local network or over a WAN. Now, the video industry already knows how to do this, and they transcode data recognizing clients, and then they dynamically split the processing between the servers and your client, and sometimes intermediate devices, to optimize your experience on the device. So that's, I think you were already referring to this, Chris, and that's what we see as well, is that future visualization technologies will actually recognize the volume of data, and they'll recognize where you're sending it. They'll recognize the capabilities of your client, and they'll determine how much of that visualization, and then also based on the volume of data, needs to be done on the server and how much needs to be done here, or maybe even in an intermediate device. So I would agree. Today, all of the visualization tools that exist, all the legacy visualization tools that exist, can visualize Hadoop data using the standard connectors. But the real opportunity, which we're already seeing, is new companies that are actually implementing, I'd say, like dynamic visualization that recognizes all of those components when they deliver visual results.
Any other questions? Well, thank you for your time. Have a nice evening. And yeah.